Okay, so today we're going to go into function inverses, and we're going to learn how to find function inverses, learn what they look like on graphs, and then we'll be good for today. So what is an inverse of a function? An inverse of a function is a relation that maps the range function back to its domain. So what does this look like? Well, it basically looks like the inverse of the function mapped to the range or output of a given function mapped to its domain or input. So basically, let's say we start with this function right here. This function is f(x). So we start with this function and we notice that the domain is -4 and the range is 2. More specifically, we can write this in coordinate form, which looks like this, -2. Well, what this is basically telling us is that the inverse of that, so let's say that this is the inverse, gx is the inverse switches the input and the output in the inverse. And so the inverse coordinate would be -2 and -4. And so what you see is that what we did there was we went ahead and switch the input and the output. The input being your domain and the output being your range. Okay, so the relationship between the inverse and the difference between the function and its inverse is the domains are switched. The domains and ranges are switched. Okay. So now let's look at inverse notation. So how do we get the actual inverse function or the equation given that we start with our original f(x)? So here we start with a function, and that function is f(x) equals 1/2 times x. And then the inverse would be gx is equal to 2x, okay? And so basically, let's say that we want to test whether this is in fact the inverse of that function f(x). Well, if we want to test this, what we're going to want to do is plug in a x value, get that resulting value, so what is the range, and then plug in the range to the input and see if we get the output. So let me show you what I'm saying. So f(x) is equal to 1/2 times x. So let's say the x I want to put in is 6. So I'm going to put in 6. That means I'm inputting 6, which is going to be my domain value. And now I want to see what I get as a result of inputting 6. Well, 1/2 times 6 is 3. Okay, so now I want to see if my inverse is in fact the inverse function of 1/2 times 6. So what that means is this is my inverse. What I'm going to do is instead of putting in 6, I'm going to put in my resulting range value. So I'm going to put in the 3. And what I want to get is my original input. So 2 times 3 is 6. So what you see here is that I start with the original input, right? My 6. And I get my resulting value, my output, which becomes my range. So this actually would look like 6, 3. Okay, and so to check whether this function is in fact my inverse function, what I did was I go ahead and substitute that into the equation. And what I want to make sure is that I get my same resulting input. So this would actually be 3 and 6. So there you can see that my domains and my ranges have been switched. And because my domains and ranges have been switched, this function would in fact be my inverse. Okay? Any questions about what I'm doing here? So basically what I'm doing is I'm going ahead and I'm checking that gx equals 2x is in fact my inverse of my original function, f(x) equals 1/2 times x. So I'm making sure that gx is in fact my inverse function. Okay, so any questions here? Okay.
No, ma'am.
Okay. So now I'm going to go ahead and move on to finding an inverse graphically. So here we have graphed fx equals 1/2 times x, and that will be this graph right here. And what else is being graphed is its inverse, which is 2x. So this one right here. And what we see here is that whenever we graph a function and its inverse, the inverse function is reflected across the line y equals -x. So y equals -x is that red line right there. And so what you see is that our original fx is reflected across y equals -x to create the inverse of fx. And what you can also see is that these coordinates right here do the same thing that we saw before. We start with our original input or domain and our original output or our range. And in the inverse, the domain or the range becomes the domain, and the domain becomes the ranges. So you can see how we went ahead and switched those coordinates from our fx to our inverse function. Okay, so what does this show us? Well, this shows us that the points mirror each other, and an original point, AB, or xy, whichever your preference is, on the original function becomes BA or yx, right? So we can see that those coordinates are actually being switched between the original function and the inverse. So now we're going to go ahead and find out, okay, say that we're given an original function like this, fx equals -4x minus 8. Well, how will I get the inverse on my own of fx? Well, the way that we can do that is you're going to take the original equation and what we learned is that fx is equivalent to y, so we can actually replace it with y, where y is our output. Hold on 1 second.
Already got 4. What happened to your teachers?
Hold on.
Oh, I'm sorry, they're doing the opposite. They're looking at it, okay?
Okay.
I want to get one there, one there, one there.
Okay. Okay, sorry about that. Okay, so you're going to replace your fx with your y like you see here. And in order to find the inverse, what you want to do is switch your x and your y, because that's what happens in your inverse, right? You start with your original x, y, and then whenever you get your inverse, it becomes yx. And so as you can see, it's switched. So in the equation, you want to do the same thing. So it becomes x equals -4y minus 8, right? And so what we can see there is we switch the x and y. And so now what you want to do is you want to go ahead and go back to where y was isolated by itself. And so I'm going to show you how to do that. Just give me 1 second. Okay. So now we're here at this equation. So let me go ahead and erase this. And so now what we want to do is isolate y again so that we get y equals on one side. Okay, so how do we do that? Well, the first thing I'm going to do is add 8 to both sides. So now I get 8 plus x equals negative 4y. Okay, now I need to further isolate y. And the way I'm going to do that is divide by negative 4 on both sides. Okay. And so now I can cross out this one. And now what I'm going to see is, can I divide by negative 4 here? Well, yes, I can divide by negative 4 on this function right here. And what does that become? Or when I do the division, it becomes negative 2. Okay. Now I want to see, can I divide these two together? I cannot divide. Remember, this has like an imaginary 1. I can not divide negative 4 by 1. And so all I have to do is drop it down. And so there I get my inverse function. So I started my original function, which looks like this. And now I have my inverse function. So basically what I did is, the first thing I did was to replace fx with y, switch x and y, and then solve for y. So I've isolated y again onto one side, getting my inverse function. And what I can do is, now I have to change back that y to an inverse function. And my inverse function is represented by a symbol that looks like this. So basically it just contains my fx, but now I have an exponent of negative 1 on the top, which represents my inverse. And then all I have to do is put my equation back together. So I just went ahead and replaced my y to my inverse notation. Okay, any questions about this? Questions? Oh my goodness, sorry guys. Okay, so now that we have a graph, how can we go ahead and determine if a function is inverse? Well, in order to determine if a function is inverse, we can use the vertical line test. So we're going to use the vertical line test to determine if a graph and its functions on its inverse are functions. So what does it mean for something to be functions? Well, remember that a function means for every x, there is exactly one y. So for every x, there's exactly one y. So what we want to do is determine whether this graph and its inverse are functions. So we're going to use the vertical line test. So vertical line goes up and down. And what we want to see here using the vertical line test is whether, whenever we draw those vertical lines, if they have more than one coordinate on each line. For each of the different graphs. And so what we see is that each of these, the function and its inverse, pass the vertical line test, and so therefore the inverse is a function. So this would be our inverse. And this would be our function. And what we see is that both of those pass the vertical line test, so both of those are in fact a function. Now we'll test this one. And what we want to see is whether both of those graphs pass the vertical line test. And what we can see there is that the inverse function does not pass the vertical line test, right? Because there are coordinates on this inverse function right here. That contain 2 coordinates on each of those vertical lines. So an example are these right here. So that means that the inverse of our original function is not a function, meaning it does not follow the criteria that for every x there is exactly 1 y. Okay, so that's how we would test whether the inverse is a function. So what about the horizontal line test? Well, you can use the horizontal line test to test if any horizontal line only intersects a graph once and the graph has an inverse function. So basically we can use the horizontal line test to determine whether an original function has an inverse function. So what you'll do is you'll draw horizontal lines. And if it passes the horizontal line test, then that means that that function will have an inverse. So we can see here that this one passes the horizontal line test. Well, if it passes the horizontal line test, then we can get an inverse out of it. But this one, well, as you can see right there where those 2 red dots are, that function does not pass the horizontal line test, so that means we cannot get an inverse function. So we use the vertical line test to determine if an inverse function is in fact a function. So it follows the criteria for every x there's exactly 1 y. And then we use the horizontal line test to test if a graph or a original equation in fact has an inverse function. Okay. So what did we learn today? Well, we learned that the inverse of the function is a relation that maps the range of given functions back to its domain. So if we start with our original function, what we'll notice is that the inverse switches the domain and the range of the original function to get its own coordinates. So basically what it's doing is it's switching the domain and range around. Okay? What we also learned is that the graph of an inverse of a function is reflected across the line y equals negative x. So if we have an original function, we can find the inverse function on a graph by using y equals negative x. And what we'll also notice is that by doing so, all the AB original coordinates will now get mapped to BA. So for example, let's do this one. This one is 1 and 0. So this will be our original function. And we will see that when it maps to its inverse, those will be switched. And so it'll become 0 and 1. The next thing we learned was how to find the inverse function. So if we start with an original equation, we have certain steps to go about finding that inverse function. And then what we also learned is how to determine if a inverse is in fact a function. So it follows for every x, there's exactly 1 y. And then we also learned how to determine if an equation that we start with has an inverse, and that's when we use the horizontal line test. But what we'll go ahead and do tomorrow is go over some practice problems so you can see this a little bit better. But this is basically just an overview of how we get into function inverses. So is there any questions about anything we went over today? Okay, so tomorrow we'll go over some practice problems. Oh my goodness, guys, my nose is so itchy. Okay, so tomorrow we'll go over some practice problems. So for today, You guys may log off and I'll see you guys tomorrow. Bye, guys.
Bye, Miss. Have a good day.
Bye, you too.
Bye, miss.
Bye.